So far we've looked at vector addition, where you add two vectors together, and scalar multiplication, where you multiply a vector by a scalar. Today we're going to talk about one of the ways where you can multiply two vectors, and there's two different ways. There's, first of all, what we're going to talk about today, the dot product. The dot product of u and v, where u is a vector u1, u2, and v is a vector v1, v2, is defined as u dot v equals u1, v1 plus u2, v2. The dot product of a three-space vector, or three-space vectors, is u1, v1 plus u2, v2 plus u3, v3. And this can be extended to any dimension. You're going to multiply the corresponding components and then add them all together in the end. This product is going to yield a scalar. The answer will be a scalar number, not a vector. And so sometimes it's called a scalar product. Properties of the dot product: it is commutative, so it doesn't matter which order you go in. It is distributive, so you can distribute the dot product over a sum, like so. And you can move your constant scalar multiple in and out and to whichever position you want. The zero vector dot any vector is going to be the number 0. And v dot v is going to be the magnitude of v squared. Now that one should be fairly straightforward to see because we know that the magnitude of v is the square root of v1 squared plus v2 squared, and if you have one, a v3 squared. So if you square that, you get v1 times v1 because it's v dot v, v2 times v2, and v3 times v3. So that's just a little property that we can use. So let's do some examples. I've got u is 1, -3, v is 4, 5, and w is -2, 7. So u dot v is going to be 1 times 4 plus -3 times 5. And that'll give me 4 minus 15, which gives me -11. u dot v times w. Now it's important to understand what's going on here. U dot v is a scalar. W is a vector. So this is a scalar multiple of a vector. And we already know that u dot v is -11. So that's -11 times -2, 7, which is going to be -11 times -2 is 22. And -11 times 7 is -77. So we have 22 and -77 as our answer. Now it wants us to do u dot 2v, and there's nothing wrong with multiplying v by 2 and then taking the dot product, but we can use the property that this is equal to 2 times u dot v, and we know that u dot v is -11. So this gives me -22. And then finally, let's do the magnitude of v squared. We know that that is v dot v. And since it's not on my screen right now, v was 4, 5. So this would be 4 times 4 plus 5 times 5, which is 16 plus 25, or 41. The angle between two non-zero vectors is an angle theta between 0 and pi, which exists between their respective standard position vectors as shown here. So if this is v and this is u and they're both in standard position, we're looking for the acute angle between them. Okay? And there's a formula for this. It is if theta is the angle between two non-zero vectors u and v, where theta is between 0 and pi, then the cosine of theta is equal to u dot v divided by the magnitude of u times the magnitude of v. Now since the magnitudes are always positive, the possible orientations for the two vectors are as follows. They could be opposite directions of each other, meaning there's a pi vector there and your cosine of theta is, a pi angle there, and your cosine of theta is -1. Theta could be between pi over 2 and pi, meaning it's one of those angles that's obtuse, and that is the cosine of theta between -1 and 0. And the other option is that it could be pi over 2, so it could be a right angle. And I think I might have misspoken earlier. I said it had to be an acute angle, but what I really mean is we're looking for an angle that is not greater than pi. So if you have two options, it's going to be the smaller one. Okay, so you could have this theta, which is pi over 2. You could have an acute angle here where the cosine of theta is between 0 and 1, and that gives you an acute angle between 0 and pi over 2. Or you could have theta equals 0 where cosine of theta equals 1, which just means the two angles point in the same direction. Orthogonal vectors. Now this is a specific case. When u dot v equals 0, that will make this entire fraction equal to 0, which means that the cosine of theta is going to be 0. And if the cosine of theta is 0, we know that theta has to be pi over 2 because the inverse cosine of 0 is pi over 2. So two vectors are orthogonal when u dot v is equal to 0. So this word orthogonal sounds really strange, and you're looking at these two lines and you're saying, hey, those lines are perpendicular. Well, the terms perpendicular, orthogonal, and normal all mean the same thing. Basically, they mean that two objects meet at a right angle. So which one you use depends on which two objects you're comparing. Orthogonal is the word that's typically used for vectors. So we don't really say vectors are perpendicular, we say that they're orthogonal, but it means kind of the same thing. Now, one thing that's important to understand is that the 0 vector is going to be orthogonal to every vector, because 0 dot v is equal to 0 for all vectors v. Two non-zero vectors are orthogonal if and only if the angle between them is a right angle pi over 2. So let's do some examples with this. It says find the angle between the following pairs of vectors. I've got 3, -1, 2, and 0, 1, 4. So I'm going to find all the pieces that I need first. I know I need u dot v. And I get 3 times 0 minus 1 times 1 plus 2 times 4. And that gives me 0 minus 1 plus 8, or 7. I need the magnitude of u, which is going to be the square root of 3 squared plus -1 squared plus 2 squared. And that gives me the square root of 14. And I'm going to need the magnitude of v, which is the square root of 0 squared plus 1 squared plus 4 squared, which is the square root of 17. So we know that the cosine of theta is equal to u dot v divided by the magnitude of u times the magnitude of v. So cosine of theta is equal to 7 divided by the square root of 14 times the square root of 17, or 7 divided by the square root of 238. So now that means theta is equal to the arc cosine, or the cosine inverse, whichever notation you prefer, of 7 divided by the square root of 238. Now, if you're asked for an exact value, this is the exact value of theta. It's not pretty, but it is an exact value, and there's really no way that we can turn this into something really nice with a multiple of pi. So if you want to know what a decimal approximation, you can put this in your calculator in radian mode, and you get 1.100 radians. If you get something else, you're probably in degree mode, and you would need to switch it because unless it specifies otherwise, you are going to be expected to use radian mode for this. Okay, so for this one, we'll do the same thing. U dot v is going to be 0 times -1 plus 1 times -1 plus 3 times 0, which gives us -1. The magnitude of u is going to be the square root of 0 squared plus 1 squared plus 3 squared, which is the square root of 10. The magnitude of v will be the square root of -1 squared plus -1 squared plus 0 squared, which is the square root of 2. So the cosine of theta is going to be -1 over the square root of 10 times the square root of 2, which is -1 over 2 square root of 5, and then if you rationalize it, you get -√5 over 2 times 5, so -√5 over 10. Theta will be the arc cosine of negative root 5 over 10, which is approximately 1.796 radians. So very similar to the last one. Now for part C, we have u dot v equals 3 times 1 minus 1 times negative 1 plus 2 times negative 2, which gives me 3 plus 1 minus 4, which gives me 0. Now at this point, you can keep going and find the magnitude of u and the magnitude of v if you want to, but it's not going to do anything for you really, because if this is 0, we know that it's orthogonal. We know that cosine of theta is 0 over something. We don't know what that something is, but it's something. And of course theta is going to be pi over 2 for every orthogonal angle. So at that point you can stop. Now if you happen to know the angle between two vectors, there is an alternative method for finding the dot product. Using this formula cosine of theta equals u dot v over the magnitude of u times the magnitude of v, you can multiply both sides by the denominator and use this to find u dot v if you need to. So for example, with this one, I've got the magnitude of u is 5, the magnitude of v is 4, and the angle between them is pi over 3. So notice it doesn't really give us enough information to find u dot v using the original definition. So this is the kind of instance where you would want to use that. So u dot v would be 5 times 4 times the cosine of pi over 3, which is going to be 20 times 1/2, or 10. Now in space, instead of thinking about the slope of a line for the direction, we want to measure direction in terms of angles between a non-zero vector v and the three unit vectors I, j, and k. So the direction cosines are as follows. Cosine of alpha is v1 over the magnitude of v. This is the angle between v and I, so you can see that here. Cosine of beta is v2 divided by the magnitude of v, so that would be this one here, the angle between v and j. And cosine of gamma is equal to v3 divided by the magnitude of v, which is the cosine between v and k, and the angle between v and k, and you can see that there. So now we can write any vector in the form cosine alpha I plus cosine beta j plus cosine gamma k. And notice that this is a unit vector in the direction of v, so this is going to give you a magnitude of 1 if you were to work that out. So if I wanted to do an example where it says, for example, find the three direction angles for v, which is 2, 5, and 7, the cosine of alpha, which is v over the magnitude of v. Well, we kind of need the magnitude of v first, so let's find that. The magnitude of v in this case would be the square root of 2 squared plus 5 squared plus 7 squared, which is the square root of 78, and that does not reduce. So cosine of alpha would be 2 over the square root of 78, and alpha would be the arc cosine of that, which would be about 1.342 radians. Cosine of beta would be 5 over the square root of 78, so beta is the arc cosine of that number, which would be about 0.969 radians. And then cosine of gamma would be 7 over the square root of 78, so gamma would be the arc cosine of that, which is about 0.656 radians.